Hey guys, it's Young Math Tutor here, and today we'll be going over how to find limits at infinity. In other words, we'll be finding the horizontal asymptote of a function by using the limits. Now, in order to do this, first we're going to need to know these three basic rules, right? The first one will be if the numerator degree is less than the denominator degree, then the horizontal asymptote is y equals 0. So the horizontal asymptote will be equal to 0. And in case you don't know, a degree is the highest power in a function. So for example, we have 3x squared plus x plus 1. The highest power is 2 here, so that would be the degree. And in terms of a fraction, say we have 3x plus 1 over 2x squared plus 5. This would show how the denominator degree is greater than the numerator degree, or in other words, how the numerator degree is less than the denominator degree, because 1 is less than 2. And so in this situation, we get the horizontal asymptote is y is equal to 0. And so that is pretty much the first rule that you need to know. The second rule that you want to know is that if the denominator degree is equal to the numerator degree, then the horizontal asymptote is y is equal to the numerator coefficient over the denominator coefficient. And so in other words, say we have 2x squared minus 5 over 4x squared minus 3. Then by using this rule, we'll know that it would be 2 over 4 because the coefficient is right here and right here. And so we get 2 over 4, which is also 1/2, right? So that would be how you'd use this rule. So it's very simple. I think this rule makes it probably the most straightforward. You just take the number in front of the variable, and that's the answer. Now, the third rule is if the numerator degree is greater than the denominator degree, then the horizontal asymptote is the horizontal asymptote is uh, the horizontal asymptote does not exist. And so what this means is that there's no horizontal asymptote, and the limit would be either negative infinity or infinity, depending on the function. So in this case, what you do is you'd plug in. So say the problem is saying the limit as x approaches infinity, and there's giving you a function, right? Say it's x squared plus 1 over something, right? Like 2x plus 5. Now, the numerator degree is greater than the denominator degree, and in this case, you just say there's no horizontal asymptote, and the limit is, and you'd plug in infinity for x, and you'd see that gives you a positive infinity, right? And so then that would be your answer. So that is also pretty simple. You'll get the hang of it after you do food practice problems. So let's go to our first practice problem. So this question is saying, find the limit of 3x squared plus 1 over 2x minus 5 as x approaches infinity, right? And we can use a rule where it says that the numerator degree is greater than the denominator degree because 3x squared, the 2 is greater than the 1. And that shows that the horizontal asymptote does not exist, and the limit would be, so if we plug in infinity for this, we get 3 times infinity squared over 2 times infinity, right? And both these infinities are positive because when you square something, it's always positive, and the bottom, it's already plugged in a positive infinity. And so the answer for the limit would be positive infinity. And that would be your answer. The horizontal asymptote does not exist, and the limit is positive infinity. So it's pretty simple, straightforward. The next question is telling us to find the limit of 3x plus 1 over 5 minus 2x as x approaches negative infinity. Now in this case, we can see that the the degrees are the same in both the denominator and the numerator, which means then we can just find the numerator's coefficient, which is 3 over here, over negative 2, which is the coefficient for the denominator. And so our answer would be 3 over negative 2. Or y is equal to negative 3 over 2 would be our final answer for the horizontal asymptote. Right? Very straightforward. When the degrees are equal, you just find the two numbers in front of x and you set them over each other. Now our third problem is telling us to find the limit of x squared over 3x plus 3 as x approaches negative infinity. So now we can see that the numerator degree is greater than the denominator degree. And so in this case, the horizontal asymptote does not exist. And so the limit is equal to, now we just plug in negative infinity. So negative infinity squared over 3 times negative infinity plus 3. Now in this case, negative infinity squared, anything squared gives us a positive number, so we get positive infinity over, and negative infinity times 3 gives us all basically negative infinity because it's an infinite number. And plus 3 still gives us negative infinity because it's, an infinite number. So we get positive infinity over negative infinity, which is essentially negative infinity because a positive divided by a negative gives us a negative. So this would be our answer for this type of problem. So that's one thing you need to look out for. You have to plug in a negative infinity, and you have to make sure when you're, solving it out that you check and make sure that it's, going to equal to negative infinity. And so our fourth question is saying find the limit of 2x cubed over 3x squared minus 2 as x approaches negative infinity. And so this is also another case where the numerator degree is greater than the denominator degree. And so all you do is you say the horizontal asymptote does not exist, right? And now you plug in negative infinity. So you get 2 times negative infinity cubed over 3x, 3 times negative infinity squared minus 2. Now the top, the numerator, anything cubed stays negative, so we get negative infinity. And the bottom, negative infinity squared gives us positive infinity, right? And so then this is similar to the last problem. A negative divided by a positive gives you a negative, so the limit is negative infinity. That would be your answer. And so let's look at these types of problems, right? Say you have a square root over, your fraction. And so in this situation, what you'd want to do, you just want to sort of think of it as first you'll just take the number with a variable, right, attached. So let's say I'm just going to do like this, 4x squared, the square root of 4x squared over the square root of 3x squared, because these are the leading coefficients, or the numbers attached to the variable with the highest degree. And so now, if you simplify this, the square root of 4 is 2, and the square root of x is x. And we can't find the square root of 3 without having like a messy number, so we just leave that as square root of 3. And the square root of x is x squared is x. And so now we have something where we can apply the rules, right? And these have the same um, degrees because they're both 1. So we can just take the leading coefficient, which is 2 and root 3. So we get root 2 over root 3 as our answer for this type of question. So for the ones with radicals, all you have to do is take the numbers that are in front with, a variable attached to them, and you want to separate it for the rest of the, function, and then you just simplify them by simplifying the radical so that, it's from 4x squared you get 2x, and then you can apply the rule, and then you get this as your answer. But you'd write y equals 2 over root 3 as your answer. And so let's just look at another example. Say for this one, you do the same thing. The limit of, square root of x squared plus 1 over 4x minus 1 as x approaches infinity. All you have to do is take the square root of x squared over 4x, and that gives you x over 4x. And so now we can actually use our rule, or you can just simply divide by x and get 1 over 4. But, the coefficient over here is 1, and the coefficient over here is 4. And so that also works. So you get 1 over 4, and so our answer is the horizontal asymptote is y is equal to 1 over 4. And that would be your answer right here. So this is pretty much it for finding limits at infinity. So sort of all you have to remember are these 3 rules. Whenever the numerator degree is less than the denominator degree, then the horizontal asymptote is y is equal to 0. Very simple. If the denominator degree is equal to the numerator degree, then you just take the coefficients and you put them over each other. So the numerator coefficient over the denominator coefficient. And if the numerator degree is greater than the denominator degree, then it does not exist, and you just plug in either a negative infinity or infinity, and that would be your limit, and that would be your answer too. And then for limits involving square root or like the radical, all you have to do is separate it, simplify it, and then apply the rules, and then you'll get your answer. And that is all for today's lesson. Thank you for coming. And if you have any questions, leave them in a comment down below. And thank you.